In New Zealand, the amount of irrigated land has been increasing at an unprecedented rate over the last 10 years. When you do introduce irrigation, you've got to be careful that you're not creating more drainage or that you're minimising the additional drainage that might occur from that irrigation. So our research has developed the precision irrigation method to try and minimise that drainage.
To do that, we have a range of sensors that can be used in the field to capture very high resolution data. We got all these points for each farm, several thousands of points per hectare, that allows us to generate maps. One of these sensors is measuring electrical conductivity of soils, right? And when you map that property of a space, it gives you a map of property that's basically related to soil texture and soil hydrology, right? So it's a tool for us to pull apart different zones that need to be managed differently.
So that's where the variable rate control comes in. So on this pivot, each sprinkler is controlled using a wireless system, a bit like our soil moisture system. So each sprinkler can be switched on individually according to the map that we produce from our soil moisture monitoring. So we can fine-tune the irrigation placement, the placement of the irrigation water. And what we've found typically from our trials, where soils are quite variable, we can save 10 to 20% of water. We put sensors in the ground at 2 depths, and the depth that we put them in depends on the crop that is growing. So for a wheat crop, the roots would go down to 1 metre or more. For vegetable crops, maybe only 1/2 metre. For pasture, about 1/2 metre. So one in the topsoil, one in the subsoil, within the rooting depth of the crop. Those soil moisture sensors are gathering information which is transmitted to the electronics at the top of this node. The electronics, you can see this green bit here, and there's some solar panels here which power the whole system. And then the information is radioed via the antenna to the gateway that's behind me. And we can send that soil moisture data every second, every minute, every 10 minutes, every half an hour, whatever. To record an irrigation event, here we're sending the information every 15 minutes.
So what's exciting for us is that we can look at how the soil moisture has been evolving over the last few days, and we can see if we're still into that sweet spot where we don't have runoff, we don't have the bucket of water overflowing, but we are not too low in water.
Now that's really important for several reasons. We're saving that water that might otherwise drain and cause nutrient leaching. And in some cases, farmers, their allocation of water from the regional councils is insufficient. So if they can save 10% water here and apply it to another crop which would otherwise not be irrigated, then they will get more yield, more productivity. So we're converting that water to plant growth rather than wasted drainage water.